Hello there, this is James at my PE exam, and what we're going to do in this particular tutorial is we're going to address what is really quite a tough question, a really quite tricky question on, this is actually on a paper with the OCR exam board, okay, so it really draws out some ideas of impulse, which I think are like the most elevated things that we need to prepare. So we need to, if we have a look at this, then we can kind of really grasp this concept as well as we can. So it's question D, it's the 20 marker as it was from in sort of the specification between 2008 and 2015. But what we're saying here is that this illustration is a force time graph, and of course as soon as it's a force time graph it's an impulse graph, and it's the takeoff of a Fosbury flop during the high jump. Okay, so when we say takeoff, that makes me realize that the collision is between the foot and the ground. So that's what we're talking about, the collision between the foot and the ground. That must be the two colliding objects. And it's saying here, use Newton's laws of motion to explain the relationship between impulse and the motion of the high jumper. Okay, we could probably have a good go at that with our knowledge during the takeoff. And explain how the high jumper uses centre of mass in order to maximise performance. Now I'm not going to address this bit yet. Later on in the course you will be able to do that, but we're not going to address that bit yet. But we are going to explain the relationship between impulse and decreasing momentum when landing on the safety bed, which is in effect separate from this graph. This is about the takeoff, okay? So the first thing I'm going to do is I want to address this part of the curve. So when in my answer, I'm going to sort of do a section which is A to B. In fact, I'm going to change the colour of what I've just done so we can see it a little bit better. So we're going to do A to B. A to B. So what's happening in this point? Well, the first thing I want to do is I want to kind of define impulse, okay? So I'm going to say, I'm going to write in here that impulse, just to remind ourselves, impulse equals force times time. So I want to put that as part of my answer. So that's going to go in. Another part of my answer related to this part specifically is therefore that impulse between point A and point B equals 0, because look, we have a negative, we have a neutral profile here. The impulse is neither increasing positively nor decreasing negatively, so therefore we have impulse which is 0.